Part C. Consider the function f defined by fx equals e to the x sine x between 0 and pi. And this is actually the same as our function of y equals here, just to make the connection. The question for part C says show that the function has a local maximum value when x equals 3 pi and 4. So maximums and minimums occur when the first derivative is equal to 0. So let's sub in x equals 3 pi and 4 into our first derivative, and let's hope it equals 0. So we're subbing 3 pi and 4 into here. This will be e to the 3 pi on 4. Now sine of 3 pi on 4, sine of 3 pi on 4, plus cos of 3 pi on 4. Our knowledge of what this is, sine of 3 pi on 4, 3 pi on 4 is over here. We would use the triangle of pi on 4, 1 root 2 and 1. Sine is 1 on root 2 and it's positive. And cos is also 1 on root 2, but it's negative. So we're going to get 1 on root 2 here. So 1 on root 2 for both this, and negative 1 on root 2 for that. So notice that this will cancel out and be 0. And then 0 times this will be 0. So we know that. Now we know that if the first derivative when we sub in our x value is 0, this is either a minimum or a maximum, but we need to prove that it's a maximum for this question. So let's sub now 3 pi on 4 into our double derivative, which is 2e to the 3 pi on 4 times cos of 3 pi on 4. Now we know cos of 3 pi on 4 is negative, as I just showed you before. It's over here, and this is in the negative cos zone. So this is a positive number times a negative number. This will be less than 0. Now, if our double derivative comes out as a negative number, therefore it has a negative curvature, which will be like this. It will be somewhere here, and this is a max. So it's a turning point, and it's part of a negative curvature. So therefore, x equals 3 pi on 4 is a local max. Okay, that's the answer to part C.